Pennies are in fact made of both copper and zinc. Lots of different ways to combine copper and zinc into a mixture. Brass is actually the same kind of mixture, also made of copper and zinc. So your goal in this lab today is going to be to determine what percentage of our penny is actually made of copper, and also what percentage of our brass is actually made of copper. Now, you actually could get on the government website and determine, since this is a penny that is made after 1982, you could find out the exact percentage you would expect. Brass can be mixed in any number of ways, so you might not know exactly what that one will be. So let's start by getting our initial masses on the analytical balance so that we can go to lots of decimal places. So now that we have the masses of our zinc copper mixtures, I'm going to do the next step in the fume hood because we're going to use concentrated nitric acid, which itself has some nasty fumes, and we're going to be producing a gas that we don't want to breathe. So we're going to add it in here, and you should be able to see the reaction. You can see the solutions have started to change color. The reaction is clearly occurring. We're going to let this progress overnight and then come back to it in the morning. Okay, so here we are on day 2, and this is the beaker that we've come back to. This one was actually the brass pellet, and you can see that we have a blue solution. Well, our brass was a mixture of zinc and copper, so when it reacted with the nitric acid, it created two things: copper 2 nitrate and also zinc nitrate. And what we have in that beaker is actually a mixture of the two. But what we're trying to do is focus on what amount of copper do we have in this solution. So we're going to use a tool called a SpectraVis, and it uses light to detect absorption. So things with color can absorb light. So we're going to work with our copper, which clearly has color, and we're going to see how much light it absorbs, and hopefully that will be able to tell us the concentration of the copper nitrate in our solution. So here's our setup. This is our SpectraVis. When I put a sample in here, in one of these little cuvettes, I put a sample in here, light passes through it, and then it will read here the absorption of that light. But before we can do that, we actually need to choose a wavelength of light that we want to do. So we're going to run a full spectrum scan, okay? I'm going to take a pre-made solution that I know the concentration of, 0.2 molar copper 2 nitrate. I'm going to fill my cuvette with that. A little bit more. And then I'm going to put this into my SpectraVis, and I'm going to run a full spectrum scan. Okay, and we can see our curve here. Let me stop the reading. We can see our curve here, and what we're looking for is a wavelength of light that is absorbed by the blue solution. So since this is measuring absorption, these wavelengths are not absorbed. There's very little. And up here they are absorbed. But this is where my SpectraVis can't read very well, so I'm going to pick a wavelength in here somewhere. So let's see if I can move to maybe there. That's probably a good wavelength, and it says that that is about 700 nanometers. So we're going to do all of our readings at 700 nanometers, okay? Okay, so now we need to understand the graphical relationship between the concentration of each solution and how much light it actually absorbs. If you look at the solutions that I've made here, you can see as the concentration goes down from 0.2 to 0.1, the solution becomes less blue. Even less blue if we go to 0.05, and barely blue if you go to 0.025. So as the concentration goes down, the color of the solution also goes down, so we would predict it would absorb less light. So we're going to actually look for a mathematical relationship. I have 0.2 in here, and the absorption of 0.2 is 1.427. 0.1 molar, and this is reading 0.807. And this is the 0.05 molar solution, reading 0.358. And the 0.025 molar solution is reading 0.174. Okay, so you have a graph relating the amount of copper in a solution, or its concentration, to the absorbance that it has in our SpectraViz. So now we have to back up and go back to our original samples that we did in the fume hood. So we had a penny and we had the brass pellets. This is what our brass pellets ended up looking like on day 2. So now we have to process this sample. Good thing that you learned how to do quantitative transfer in an earlier lab. So I'm going to carefully pour my solution into a 100 ml volumetric flask. Because I don't want to lose any of it, I'm going to rinse my beaker and pour that in. And I'm actually going to do that a couple of times because I don't want to lose any of my sample. I'm not even going to use a funnel or a stirring rod. And then I'm going to top it off to the 100 milliliter mark. And there we go. And now I have a solution that is exactly 100 milliliters. So if I can determine its concentration, I will also know the moles of copper in it. So how can I find its concentration? We're going to use our SpectraViz because we already know the relationship between concentration and absorbance. I'm going to put some in a cuvette. I'm actually going to rinse my cuvette with my solution. Okay. So now I have my solution in the cuvette. I'm going to put it into my SpectraViz. And the absorbance that it's reading, 0.454 for my brass pellets. I already had taken the penny solution and created a solution with that. So here's the penny. Again, what I will do is, because this one is clearly less concentrated, I'm going to rinse a couple of times with this solution to make sure I'm not leaving anything in the cuvette by accident. And wipe it down. Put it into the SpectraViz. And we get a an absorbance of 0.012. Okay, so we have the absorbance of our penny sample now, and you have the absorbance of the brass sample. So your goal is to figure out the percent copper in each of your samples. From the absorbances, remember you have your graph, and that relates absorbance to concentration. So you can use the equation of the line and your absorbances to find the concentrations of your two solutions. Very important, remember the two solutions that we made were specifically 100 milliliters. So if you know their concentrations and you know their volume was 100 milliliters, you can calculate the moles of copper 2 nitrate that were in those solutions. Once you know moles of copper 2 nitrate, that's the same as your moles of copper because there's 1 copper per copper 2 nitrate. Once you know moles of copper, you know mass of copper. And if you have the mass of copper and your original mass of the mixture, you can figure out a percentage. That whole string of calculations is listed in your lab in sequence, so you can follow through that. But work through from your measured absorbance all the way through to your percent copper for both brass and for the new penny. Good luck.